Welcome to Study Loop.
Okay, we have to consider the stronger compound in terms of its acidity or basicity. So we have diphenylamine. Is this a base or an acid? Remember, amines are basic, right? This is an amine. This is basic far more than it is acidic. The pKa is something absurd, like 35, 40, right? Definitely not acidic. And then we've also got methylamine and trimethylamine. Sorry, this is our diphenylamine, which we are comparing to our dimethylamine. Methyl hydrogen. So how do we determine which is more basic? Well, we're essentially saying how strongly negative is this nitrogen with the lone pair. And so the way we do this is we consider how good of electron donors are the groups that are on our nitrogen. Is methyl a better electron donor, or is phenyl a better electron donor, right? Well, recall that phenols, if we were to draw out one of them attached to the nitrogen explicitly, are somewhat electron withdrawing, in fact, because they contain sp2 hybridized carbons. And sp2 hybridized carbons, the orbital, which represents the carbon nitrogen bond, is 33% S and 66% P, whereas in the case of sp3 hybridized carbons are a quarter S and 3/4 P, right? The point being that since S orbitals are much more positive in character than p orbitals because they are closer to the nucleus, this being S close to the nucleus, that in fact sp2 carbons are somewhat electron withdrawing. So then we're saying, well, methyl groups, alkyl groups we know are electron donating, and now we found out that our phenyl groups are electron withdrawing. So this lone pair is going to be higher in energy or more negative with the alkyl groups attached than with electron withdrawing phenyl groups, right? The phenyl groups are stabilizing the lone pair, making it less reactive. Our EWG, electron withdrawing, stabilize the lone pair, less reactive. Versus the methyl groups, which increase the reactivity of the lone pair here. So the more basic is the dimethylamine. Okay, now we're going to compare methylamine to trimethylamine. And basically what we're saying here is, well, we've already established methyl groups are electron donating, and that electron donating groups destabilize the lone pair and cause it to be more reactive. So the question is 3 electron donating methyl groups more destabilizing than 1 electron donating methyl group? And the answer is, of course, that 3 methyl groups will make this nitrogen more basic than 1. Right? So the answer here is trimethylamine. It'll be far more basic with trimethylamine than just methylamine.